Let's take a moment to look at the standard deviation visually. What I have over here on the left is a data set, 39274. If you average those pieces of data, you get a mean of 5. And then what I've done over here on the right is created a vertical axis, which goes from 0 up in increments of 1 all the way up past 12. And then I've drawn that mean horizontally. So at the mark 5, I've drawn a horizontal line at 5, and that represents the mean. And you can see I have all the data points also. Here is the data point for 3, it's 2 below the mean. Here's the data point for 9, above the mean. And then here is 2, and then here is 7, and then here is 4. What I'm going to do next is draw segments from each data point to the mean. So here we go. There's one segment, another one, a third one, a fourth one, and the final one. And you can see that some of the data points are close to the mean, so they have short segments, and other data points are further away from the mean, so they have longer segments. And these segments are known as residuals. What I'm going to do next is square those residuals. So what I'm going to do visually is draw a square on each residual and sort of have it come out of the page towards us. So here's the first residual. I'll try to color that in. Here's the next residual, it's a little larger. And then here's the next one. And here's the fourth one. And then here's the final one. And each of those squares has an area. And if we add those areas up, this has an area of 4. This one has an area, I think, of 16. The next one has an area of 9. And then this one has an area of 4. And then this has an area of 1. And if we add those areas up, we get a grand total of 20 plus 14. We get a grand total of 34. So the sum of all those squares is 34. Next, if we divide that sum by 1 less than the number of data points, in other words, if we divide this sum by only 4 because we have 5 data points, we get the variance. So 34 divided by 4 is 8.5. And that is the variance. And then the final thing we have to do to get the standard deviation is just square root that result. And the square root of 8.5 on a calculator is about 2.9. So that's the standard deviation for this data set. It's a measure of how spread out the data are. So this is a very visual way to see the standard deviation. You wouldn't actually want to do all that drawing when you calculate a standard deviation and you want to do it quickly. But this visualization of the standard deviation will become helpful when we look later on at scatter plots. And that's it.